Good morning. Welcome to the session of Instrumentation Engineering. Myself, Dr. Somak Karan, Assistant Professor, Department of Applied Electronics and Instrumentation Engineering, Haldia Institute of Technology. So today the discussion topic is process control. The prerequisite to understand this particular topic is sensor and transducer, industrial instrumentation and control theory. So before we wants to know about the process control, the introductory discussion is very much required. So that's why the discussion regarding the introduction to process control will be come into the picture. So the contents of this particular lectures, if we talk about, we will go through the introductory part of the discussion, then we will proceed towards the evolution of the process control, concept, definition and type of processes, classification of the process variables, open loop versus closed loop system with practical examples. So in the first part of my lectures, that will be containing such kind of contents, and after that in the part 2, we'll be thoroughly discussing about the servo and regulatory control, feedback and feed forward control configuration, and few of the problems that we'll try to understand through the particular discussion. So if we talk about the introduction part of the process control, we have to know first that what is the meaning of the control. So control means something more precise. So if we talk about the control, to control any person, to control any instruments, what will be required part of the discussion. So what we have to do first, we have to know about the process or know about that person very well. So that's why the first thing which will be coming is nothing but the monitoring of the process or monitoring of the system or monitoring of the person. Otherwise we are not able to understand that what is the characteristics of the process or what is the characteristics of that persons also, because we wants to control. So the monitoring of such kind of process or person or system is very much important. Then the next part, for the controlling aspects, what we will try to understand that what is the purpose of to use the control. That means we have to evaluate that how the person is behaving, how the process is behaving, how the system is behaving, and what is our desire to make such kind of process or system or person to be handled. So that's why after the monitoring, the next part will be the evaluate or try to be controlled. And as per the decision has been taken by the controller or our brain that how to control the situation, then we will try to act. So that is the three major point or major three concern to control each and every aspects of the daily life or the processes is nothing but the three words we have to be kept it in our mind. That is the monitor, evaluate and act. Because we are talking about the process control, so that's why we have to understand that who will monitor in the process. So if we talk about any type of loops, that means the pressure control loop, level control loop, temperature control loop or flow control loop. So in such cases, what is the actual scenario of the process that giving me the information by the transmitter or transducer or sensors. So basically the monitoring part will be taken care by the transmitter or transducer or sensor. Then the evaluate part, that means what decision has been taken, that we have to be know, and this evaluate part will be taken care by the controllers. So the controllers will take the decision that whether we should go for the different kinds of control. That means we have to control in which manner, that will be decided by the controllers. And after the controllers giving the signal, we have to act. That means someone have to take the responsibility who will try to implement the decision has been taken by the controller. So that is nothing but in the case of the process control, which we have the final control element. One of the very interesting relationship between the controllers and the final control element, if we talk about, so controllers will not directly try to implement the decision. So controllers will only try to give the decision to the final control element, and final control element will take the initiative to implement the decision of the controller. Just take the example of a football team and its coach. Coach never will go to the field and try to be play the match. Coach will only make the target, make the strategy that how the team will perform in this particular match. And whenever the decision has been taken, then the implementation has been done by the 11 players of the football team. So that is a very interesting fact, that why such kind of monitor, evaluate and act will be considered to be as a controlling uses, and what will be the benefit of using these three criterias. Process control involves the control of the variables such as mostly the temperature, pressure, flow and level. If we talk about the evolution of the process control, obviously right now we are transmitting towards the industry 4.0 to 5.0, but the starting will be not such kind of things. initially the handheld instruments or the mechanical instruments will be coming to the picture. That is nothing but the manual control we have in the year of 1930. After that, the pneumatic instruments came into the picture in the year of 1940. The pneumatic instruments are mostly considered to be as a air control instrument. That means the pneumatic pressure or the air pressure has been used to perform the different types of operation of the controlling of instruments. And after that, in the year of 1950, the smaller pneumatic instruments, that means the sophisticated instruments, will come into the picture, and they will try to be adjusted along decade. And after that, the analog instruments. So right now we have using 1 to 5 volts, 4 to 20 milliamps. So such kind of signals will come into the picture in the year of 1960. After that, the most recent evolution we can say in the process control domain will be the nothing but the implementation of the PLC, programmable logic controller, or distributed control system in the year of 1975. After that, all the way it will be associated with the IoT, it will be associated with the different kinds of configuration of the AI and all the things, and we are evaluated each and every day in daily life in the instrumentation field. So right now we will try to talk about the concept, definition, and types of processes. So particularly we have already discussed about what do you mean by control, but what do you mean by process? What is the meaning of a process that we have to know? So we have the three types of definitions over here. Try to find out each and everything and try to be describe of each and every point here also. That is a series of action of operation or operation conducting to an end. Means that whenever a series of operation will be conducted one by one, then at the end we will try to get the final product. If we talk about the bottle filling plant of a PepsiCo, so what is the initial phase of the action? Obviously we require some bottles. The bottles in the next phase will be cleaned. Next phase it will be going to the filling station, it will be filled with the liquids or the liquids of the soft drinks. Then it will go to the cap or the capping area. After that, the capping area will go to the packaging area. So one by one operation will be conducted. You cannot neglect any one of the operation and try to be jump into the next one. So that is a very important point, that a series of action or operation conducting to an end, a systematic series of operation in a production. So if we talk about the oil plant, so initially we have taken the crude oil. After that, this crude oil will be going through the distillation column and the purification stage, and then we will try to find out the different types of products like diesel, like petrol, like aviation fuels, like gasoline, like kerosene, and all the things will come into the picture. So it is nothing but the process means it is a systematic series of operation in a production. If we talk about a course of operation, natural or artificial, so different types of natural operation will also be considered, whether it will be man-made, then it will can be a artificial operation we can talk about. So the features of the process variables, if we talk about, we are mainly concerned about the process variables. We are mainly concerned about, as I already mentioned in the last slide, we are already mentioned about the controllers. We are already mentioned about the final control elements. In the scenario of the process control, if we talk about, the controllers are mostly the hardware elements or the software programs. In the PLC we have the ladder logic diagram, so that can be considered as a software one. If we go for the electronic PID controller, that is the hardware implementation of the controller, so such kind of controller configuration can be done. Final control element is nothing but the, for the industrial aspects we can say this is nothing but most of the cases control valves, because we are dealing with the pipelines. So to maintain the flow of the liquid or steam or other things, that will be the very much requirement to maintain the flow rate in a pipeline, that can be done by the control valves. The five main process characteristics if we talk about, they are the speed of the response, spacing, continuity, periodicity, and determinacy. So they are the five main process characteristics in different aspects of the processes. If we talk about, that will be the major discussion of the concept behind the process control. Very important slide right now which we are try to discuss is the classification of the process variables. So whenever a process we have considered, that means the process have some input and the process have some output also. So this particular input, whenever we talk about, the input has been divided into the two parts. One is known as the manipulated, one other is known as the disturbance. Manipulated variables means which we are able to control, and the input, obviously we will talk about the disturbance. If we take a very good example, that we try to maintain the room temperature of our classroom or of our lab, so in such cases AC will be the major part of the discussion. So in that particular time, what is the room temperature, that is can be considered as a manipulated input variables. If I have a very hot summer time and try to measure the initial temperature of my classroom, maybe it is 35 degree, maybe it is 40 degrees centigrade, and whenever the set point has been given, that is 24 degrees centigrade, so obviously we will try to find out the error and try to take the corrective action. So whatever the parameters we are able to measure, that can be considered to be as a manipulated variables. And whenever we will talk about the disturbance, disturbance is associated with it. The examples which I just try to mention to you, that whenever a classroom or a lab we are suddenly opening the doors one by one time whenever a student or a faculty will come or out from the room. So in that particular time, the ambient temperature will try to affect to your classroom temperature. That means it can be considered to be as a disturbance. Disturbances cannot be considered as all the time by the measured disturbance. That means the opening and the closing of the doors, we can say it is a measured disturbance, because it is known things to us that whenever a room we have, so obviously some of the person will come and going out from the room, and it needs to be considered at the time of our discussion. So it is talk about the measured disturbance. Unmeasured disturbance, if we take from the same example, if our window is open for a time while and we are not able to identify that whether the room, because the curtain is closed, so that's why we are not able to identify whether the window is open or not, so that can be considered as a disturbance, but it is not in our measurable range, so that is called as a unmeasured disturbance. So disturbance is a very concerned point in each and every process control, and obviously that can be a concerning point to control the efficient output. That means controlling and the efficient output can be provided by the process output side or the process variable. Output variables, if we talk about, that is nothing but again can be considered as a measured and unmeasured. One of the very good examples, if we try to take that, the closed loop control, that means if we try to maintain the room temperature of the classroom, so in such cases the measured temperature is nothing but the room temperature, and that is a output variables which is measured. But the unmeasured, if we talk about, if we talk about the open loop control, so I have a fan and I just give the power to this particular fan, switch it on, but after that I will try to make the regulator in speed 1, but I am able to observe that the fan speed is in the full mode. That means my controller is obviously acting to maintain the rpm of the fan with nominal speed or the minimum speed, but the fan speed is maximum. That means it is a unmeasured and we are not able to take any type of decision in it. Disturbance are also known as load. So process control, most of the cases the disturbance has been defined by the term load. So whenever we have heard about the name load in a process control, that means it is nothing but we are talking about the disturbance. We have just tried to give the last input from this particular slide. If we talk about the input variables that convey the effect of the surrounding on the process, so whatever the surrounding affecting to the process, that will be nothing but we can talk about the input variables. So that's why the disturbance has been taken care in this particular discussion. Output variables means what the particular process has giving the output to the surroundings. So how the output of the process will be making the change of the surroundings, that is the important point as a output variables. One of the very good example of a CSTH we have taken, continuously treated tank heater, and in this tank heater we have the feed, that means the liquid is coming to this particular CSTH, and we have a steam line through which we'll try to heat up this particular liquid and try to take out from the chamber. So obviously if we talk about the input, so here we have the feed, one of the input, and the feed has been considered to be as a two parameters. One is the flow and the temperature, respectively denoted as Fi and Ti. Another two inputs if we consider, that is nothing but the FST, that means flow of the steam, and TST also can be considered, which is the temperature of the steam. So here we have mentioned about the input and the output variables using this example. FST is the steam flow rate, Fi and Ti are the flow rate and the temperature of the feed. F0, and that also can be considered as T0, is the flow rate and temperature of the outlet steam of CSTH. Liquid level has been denoted as H, and the heat transfer or the amount of heat has been transferred to the liquid, that will be denoted as Q. So right now if we talk about the input variable, so obviously the input, which is the feed, that need to be considered, which is Fi and Ti. Obviously the another input through which the temperature has been changing, that is called the FST, that means the flow of the steam, and TST, that means the temperature of the steam. What is the output variables? The output variables is nothing but the output of the liquid. So that's why F out or F0 is nothing but the output variables, and T0 or T only, that is the output of the feed temperature, that is also considered to be the output variables. Now, if we talk about we are only controlling a single parameter, so in such cases, if we talk about we are only controlling the flow of the steam, which is going for the change of temperature or heat exchange, so FST may be selected as a manipulated variable, but we have to be very much careful that we have considered four parameter as an input variable, but we are only controlling about the FST or the flow of the steam as a manipulated variable. So in such cases, rest of all the inputs needs to be considered as a disturbance, because anytime such parameters can be changed, and whenever these parameters can be changed, so that can be affected to your system. So that is a important part of the discussion, and using the particular examples we are able to find out that what is the input variables, what is the output variables, and what is the input variables as a manipulated variables, and what is the input variables as a disturbance. Now we'll talk about the open loop and closed loop control. So open loop means we are not taking any type of feedback from the output side. So obviously I have just given you the example of a fan, where if we talk about the input, so we have given the input of the power. After that, controller will take the decision that how much speed of the fan we have to regulate, and after that the respective control action has been generated to the process. So whenever we will give the output from the controller to the process, we have to be very much careful that whether the output of the controller will be implemented in the process or not. So as I already mentioned, we have given the fan speed of 1, but my fan is running in a full speed mode. So that means my process is not at all considering the decision of the controller. And because we are not able to identify also, because there is no feedback from the output side. Whether if we go for the closed loop control, so in such cases, feedback will be always try to be measured, error will be detected, and according to the change of error, corrective action has been taken by the controller. So next, if we go for the practical example itself, so you are able to see we have the two examples of ceiling fan and the air conditioning system. So ceiling fan already I have described about the open loop system, whether we'll go for the AC or the air conditioning system, that will be considered as a closed loop system. So in such cases, if we just try to find out the closed loop system, how the information has been transmitted initially, whenever we'll switch on the AC, so firstly the measurement sensor will try to identify that what is the right now temperature of my room. So this temperature will be considered over here, maybe it is 40 degrees centigrade, and my set point value will be 24 degrees centigrade, so error will be 16 degrees centigrade. So controller will take the corrective action or the decision, and the controller output signal will giving in the form of a 4 to 20 milliamps, or in the form of any type of current signal will giving to the final control element. So whenever the final control element will reach, so for the case of the AC, the final control element will be nothing but the compressor. So compressor will compress the air. So whenever the air has been compressed, that means using the very basic formulation of PV is equal to nRT. If your pressure has been increased, that means the temperature also has been increased. But using the expansion valve of the compressor, we are able to reduce the temperature of the air and try to go through the evaporator section and the condenser section, and try to make the airflow and the heat exchange of the inner air of your room, and try to implement or try to reduce the temperature of your classroom. Disturbance, if we talk about the opening and closing of the doors, we can say the opening of the window can be considered to be as a disturbance. So in that way, easily, whenever the process in a running condition, the present value will be reducing after certain time of period when the controller has take the action, and with this particular action the controller has been try to reduce the error behind the set point value and the present value, and whenever the set point and the present value will be same, that means error will be zero, then the controller will give the information that we have reached to the set point value or the desired condition. So this is the last case of the discussion for the part 1 of introduction to the process control. So thank you so much. We'll discuss about the rest of the parts in the next discussion of the process control or the introduction to the process control part 2 lecture. Thank you so much for your understanding and valuable time.